The next lab we are recording is heat exchange. To start, I have my calorimeter, my stir plate, my thermometer, and my stir bar. This is going to be the setup that we use for all of our reactions. My stir bar will be inside my calorimeter, and then whenever I do any form of addition of chemicals, it will always be inside of my calorimeter with the stir plate set to stir. To start, I'm going to need to add 200 milliliters of DI water to my calorimeter in order to get the initial temperature of our cold water. I have my first addition of 100 mils. Now I have my second addition. So now I have my 200 milliliters of cold DI water. Now with my thermometer here, I can let it sit and I can read the temperature recording, tell what my initial temperature of cold water is. Once I have my initial temperature of cold water and my recording of my hot water that I have next to me on a hot plate, we will then be able to mix and run in our calorimeter. Here I have my cold DI water in my calorimeter. I have 200 milliliters of it. I'm going to start taking readings of my DI water temperature every 30 seconds for 2 minutes in order to get my initial temp. I can see that I have 21.7 degrees right now as my temperature, so I will begin recording every 30 seconds until 2 minutes have elapsed. 30 seconds have elapsed, so I can read my temperature. Is at 21.7 degrees. 30 seconds have passed. I am still at 21.7 degrees. 30 seconds have passed. I'm at 21.7 degrees. And for my last reading, I'm at 21.7 degrees. Now I will take and measure my hot water that I have here to get its initial temperature when I add it. The temperature is holding steady at 65.5 degrees Celsius. So I will now take and immediately add my hot water to my calorimeter and seal. And now I will watch and wait for my highest temperature peak, and then I will be recording every 30 seconds for 10 minutes after we have reached our highest temp. We have reached our max temp at 34.4 degrees, so I will now begin my 30-minute intervals, or my 30-second intervals for 10 minutes. I'm at 34.2 after 30 seconds, 34.1 after a minute, 34.0, 33.9, 33.8, 33.8, 33.7, 33.6, 33.5, 33.5, 33.4, 33.3, 33.3, 33.2, 33.1, 33.1, 33.0, 33.0, 32.9, and now our last data point after 10 minutes is 32.9 degrees. Now I can take all my measurements to be able to calculate my maximum heat after extrapolating backwards for heat loss of my calorimeter. Now I am moving on to the acid-base reaction for my calorimeter. So I have taken and I have cleaned and dried my calorimeter. My stir bar, which I have placed inside, has also been cleaned and dried, as well as the thermometer. The reason why we do this is we do not want any contamination between the different tests with our calorimeter. Now next, I'm going to be taking and adding 200 milliliters of sodium hydroxide as my initial. So I have now added 200 milliliters of my 2 molar sodium hydroxide. I'm going to seal my calorimeter and begin stirring so that I can get my initial temperature measurement of my sodium hydroxide. To the 2 molar sodium hydroxide, I'll be adding 2 molar hydrochloric acid. I'll be adding 60 milliliters to it. So for our first reading of initial temperature, we are at 21.5 degrees Celsius. Our next reading for initial temperature is 21.5 degrees Celsius. Our next reading is 21.5 degrees Celsius. And our final reading is 21.5 degrees Celsius. So we know that our initial temperature is going to be 21.5 degrees Celsius. Just to be safe, I have measured the temperature of my 2 molar hydrochloric acid, which is also reading at 21.5 degrees Celsius. So I know that there will not be any temperature change just because of the temperature of the 2 different solutions. Any temperature change will only be from the reaction. Immediately add and close off my system. I will look and watch for my highest temperature. Once I have achieved my highest temperature, I will then begin my 10 minutes of data collection every 30 seconds to see heat loss of our system. After 30 seconds have passed from our initial temperature addition, we are at 28 degrees Celsius. After another 30 seconds, we are still at 28 degrees Celsius. So we know that that is our highest temperature. Now we will begin our 10 minutes of 30-second intervals to see the heat loss of our system. After another 30 seconds, we are at 28 degrees Celsius. After 30 seconds, we are at 27.9 degrees Celsius. After 30 seconds, we are at 27.9 degrees Celsius. Now we are at 27.9 degrees Celsius. 27.9 degrees Celsius. 27.9 degrees Celsius, 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 27.9 degrees Celsius. And now, since our temperature has not changed for over 5 minutes, we can conclude that this is our final resting temperature to calculate and extrapolate our data from. Now I'm on to part 3, dissolving salts. Here I have my calorimeter, which has 250 mils of DI water in it. It has already been stirring for 2 minutes, so I have the initial temperature at 21.7 degrees Celsius. I have pre-measured 11.81 grams of copper sulfate anhydrous in my weighboat here. I am now going to take and put all of my copper sulfate into my calorimeter and begin my observations. After 30 seconds, I'm at 26.7 degrees Celsius, and that appears to be my maximum temperature, since now I am reading at the same temperature still. So I will begin my 10-minute at 30-second intervals. I am now at 26.5 degrees Celsius after 30 seconds. Now after a minute, I'm at 26.3 degrees Celsius. Now I'm at 26.0 degrees Celsius. Now I am at 26.0 degrees Celsius. I'm at 26.0 degrees Celsius. I'm at 26.0 degrees Celsius. I am at 26.0 degrees Celsius. I am at 26.0 degrees Celsius. I'm at 26 degrees Celsius. I'm at 26 degrees Celsius. I am at 26 degrees Celsius. And I am at 26 degrees Celsius. And since that is 5 minutes without having any temperature change, I can stop here and calculate using my data that I have collected. Here is my setup for my dissolution of salts in calorimetry. So next I am using copper sulfate pentahydrate. I have 16.76 grams in my weighboat here. I again have cleaned my calorimeter and all components. My initial temperature is 21.6 degrees Celsius. So now I will add my salt. After 30 seconds have passed, I am at 21.5 degrees Celsius. After another 30 seconds, I am now at 21.4 degrees Celsius. After another 30 seconds, I am at 21.4 degrees Celsius. After another 30 seconds, I am at 21.4 degrees Celsius. After another 30 seconds, I am at 21.4 degrees Celsius. After another 30 seconds, I am at 21.3 degrees Celsius. After another 30 seconds, I'm at 21.3 degrees Celsius. 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 I'm at 21.2 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 degrees Celsius. And I am at 21.2 degrees Celsius. Since it has been 5 minutes since there has been any temperature change, this is our lowest temperature that we have gotten, so it is now at our final temperature. We can use this now to extrapolate our data using our graph. Now I have just finished up with the measurements of one of my calorimeter testings. So now I have my calorimeter here, which contains my stir bar and solution. So I'm going to take my stir bar retriever, which is located in the room, and retrieve my stir bar from my calorimeter to dry off and use for my next calorimeter trial. If you do not do this, and you end up taking your solution in your calorimeter and putting it into waste, you'll end up dumping your stir bar into the waste container or into the sink. So please remember to use the stir bar retrievers to get your stir bar. That way you do not need to retrieve it from the sink or waste container.